that you could probably want to meet. So, you know, if you're ever on Twitter and you're feeling like you just want to be thankful for something, you can hey, give a shout out to these folks for feeding you every week. So that'll be a nice thing. Let's see. Does anybody have any community announcements you want to give a shout out? Any meetups happening that you want to plug? No? No? Okay. So today we have Mr. Caleb Albritton. Okay. I was going to say that, but I was like a little bit. Yeah, I was feeling a little bit of fear there. So yeah, he's going to be talking with us today about. I can't even remember the title of your talk. It doesn't matter. Earlier, as Andrew left, none of you heard this, but as he was leaving, Caleb said, why are you leaving? I want you to be here to support me. And to which Andrew replied, Caleb, I don't want to know what you do alone with JavaScript. So we're all going to be subjected to that now. So prepare yourselves. And go ahead and give a round of applause for Caleb.
Talking about, whoa. Today we're going to be talking about building a scheduler/call stack in JavaScript using new ES6 generators. Something that's interesting to point out is that this can't be polyfilled with Babel, so I'm just going to be writing it straight inside of Chrome. Or running it just straight inside of Chrome, no polyfills, because generators can't be polyfilled. You can't pretend to stop code. You can only stop code or not stop code. So we'll get into that. Who here understands generators, or at least knows what generators are? Like 3 people. Okay, let's start off with, how to use generators and what they are in JavaScript. So, if I can see myself typing, yes, I can. Generators are denoted by this little asterisk thingy. We're going to make this little function that just adds 2 and 2 together, and it's going to yield x plus y. And that's all we want that to do. Now, if we actually want to use this generator, we're going to do 1 plus 2. However, this isn't actually going to do anything. That is running from the wrong thing. 1 second. Okay, there we go. Actually, you know what? This is the bad thing about live coding and not really having a format for your talk. I actually wanted to throw this up on the screen. This pretty much represents what I'll be doing today and the JavaScript community as a whole. We don't really think about why we should do things. We just go and do them for shits and giggles. So when there are going to be parts in the talk where you go, why would you ever do this? And the answer is, I don't know. So if you have questions, like, feel free to ask. I'm going to try to ask you guys lots of questions because I want this to be kind of a communicative format. But yeah, if you have like a WAT thought in your head, that's just Jeff Goldblum. That's all you need. So let's back into generators. So we've got this little adder function, right? And we go over here and we ran it, but we don't really get anything. And that's because we're not executing it. If we actually want to get that number, we're going to call .next because the generator returns a function that generates things. That's a generator. So now that we have this number, then we can do something with it. Let's log it in. Press that. There we go. So you see that the generator gives back a value of 3. And this is going to happen for every time there's a yield. So if we go up here and we yield 1 plus y, we can do this again and do n equals adder.next, and then log that. We're going to get the next one. So that's all fine and dandy. That's nice for iterators. If you've worked with Ruby before, you kind of like have a feel for how yielding works. But we can do even cooler stuff than that. We can give stuff to a generator. And this becomes super important later. So I know from before that this isn't actually going to log anything because we're just getting a generative function. We can call that. What's that going to do? It's actually not going to print anything. Because all the next does of the first call is reach the first yield. And that's where it stops. It waits and suspends the code for the next yield. So if we actually want to get to the console.log part, we can do this. You get hello world. It's incredibly important that this actually works. The blog post that I kind of built this whole thing off of, on top of was actually written in 2010, back when generators were just like a thought as part of the spec. And this was incredibly important. So there, let's talk about how we can actually build code that looks similar to this. Actually, you know what? Let's go ahead and wipe all that. I'm just going to write some function and show you how, like, what our end result is going to look like. Now, is that cool or what? Like, would you rather do some URL and then pass in some callbacks where you get the data, and then have to pass in anonymous functions, and you get like all this levels of indentation, and no, nobody likes that. I want it to look like all the other programming languages that I'm used to because JavaScript. So how do we make this work, right? We've got this thing that needs to yield next, and it needs to do it over and over again. For instance, if I want it, where's my cursor? There it is. So I come over here and I log this piece of data, but I also want to do some more stuff. So I don't know. Maybe I thought my IP address changed, and I'm doing this thing again for some reason. But what I need to happen is for this yield to automatically be executed and pass the value over to the next, to the left-hand side. So how are we going to do that? Let's get into how we're actually going to build this. There's a few things that we need to understand. One is trampolining, where you return a thunk and then somebody calls that function later. So let's go over to, which file is that? There we go. Go over here, and we're just going to yield hello, and we want to log that. Or not, we just want to call it. So the exec function is going to be the entry point to our scheduler. So let's go over here and actually write our scheduler. Scheduler is not a generator. It is just a regular function that takes generator. So what do we need in a scheduler? We need a call stack. We need to know where everything is and what order it is. And then we're going to need to bounce stuff out of here. So let's write that. And all this function does is really just call that. So what is this return value? Well, first it's a generator. We kind of need to know if it is a generator, so let's do that. Let's go and define that up here. So if you can't tell, Not only was I crazy enough to think this was a good idea to write in JavaScript, I also thought it was a good idea to live code it. And because JavaScript, don't ask, right there. And I hate ternaries. So now we got that part. What do we want to do with this? Well, we need to push it onto the stack because we're going to execute it later. And let's make that undefined. And let's get the last generator that we wanted off the stack. And the return value is going to be value of the returned generator that we just passed in. So literally, we're going to take the generator, call next on it, and pass in the last value that we had. And that's how we're going to get all of these flowing pieces of code that yield and yield and yield all the way down, and they will all execute. Then, oh, no, we did that part already. Let's just go ahead and run that. We've got that. And now, we've got that main function over here. Theoretically, whoops. Oh, whoops. I renamed the variable. It's actually the generator. There you go. It's actually running. You can't see it yet because we're not logging anything. But the scheduler's working. It didn't throw out an error. That's the best part. So after we've got that, let's go over here and do some other things. We want to write a little HTTP library to represent that little request thing that we built. So let's do that. OK. We haven't implemented this part yet. So let's assume that XHR is some function that takes a callback when it's completed. Let's go ahead and write that part. Because this one doesn't care about our scheduler. It doesn't care about anything. It just cares that it can do something after something happens. So let's go ahead and do some Ajax. I know everybody's thinking about Deadpool when I said that. So as you can see, this continuation is really just a callback that takes this stuff. But we don't care about that. We don't have to worry about callbacks in our code over here. We just want it to run, right? So this continuation I passed down over there is actually being yielded over here. Let's go and implement that in the scheduler. I know this is a really heavy talk, so if you have any questions, feel free to ask. And I'm just using symbols here because I don't like to use strings for this type of thing. And the is generator still needs to stick around, but we're about to get into the meat of how this thing actually works. All of this is going to go into what every programmer's favorite thing. Yeah, you saw that. That's where it's all going, and I'm bad with indentation. Yep, Yep, that's it, right there. So let's add a few more things. If this return value is suspension, we want to stop the code, right? So we're just going to break out of the loop. If it's a continuation, we're going to bounce. Like, we're out of here. We're going to set the return value to the function that we're inside of. Otherwise, we're just going to pop the last thing off the stack. After that, we still want to get the last generator, and we still want to set the return value. One thing we want to check for, though, is if it's not a generator, we're going to bail. So now, we're going to do something a little cool. And by cool, I mean like you should never, ever do this. Okay, so everybody knows what set timeout does in JavaScript, right? Oh, no? Okay. Well, it stops execution, or take that back. It doesn't stop what comes after this line, because this line still executes, but it waits a certain amount of time to execute this callback right here. This callback is actually just to the bouncer. So when set timeout comes back and calls this, it bounces back in here, right where the continuation was set. It calls that, everything gets rewound again and starts executing. So what can we do with that? Let's go and make this thing sleep, because that's always useful. That would be probably, that's a little long. Let's do that. Oh, and if this actually runs, I typed it. Perfect. Man, that feels good. The world isn't calling. That's a problem. Cheat real quick. That really just happened. Adam, why you do this? Well, that's where it opened the file. Okay, never mind. One second, guys. This is a lesson in why you don't live code. There we go. Okay. Else? All right. So
How many of you people kind of got lost when we started yielding and passing in some continuations? It's like, we all good? No, okay, we're not all good. This is important. I don't want to keep going unless people understand this. So, right here, when we're passing in the generator, all we're doing is initiating a call stack, which is an empty array, and that's what we're going to push the values from the previous generators and all the current generators that are being suspended onto. And that's what's happening up here. If it's a generator, we're going to push it on, and then the return value is undefined because we didn't call it yet. And then we're going to set it down here when we pass a different value to the next generator. Now, the continuation part is very important. So over here in this XHR function, all I did was wrap it so that we didn't have to worry about the continuation. So let's go ahead and do the thing. Let's let data equal request from p.json test. Now, let's just go ahead and see if that runs. If it does, I'll be happy. Nope, it's undefined. We've got other issues. But before we get into fixing those, this continuation right here, this continuation gets picked up. This keyword is all we're checking for inside the scheduler right here. When it hits that, it's setting the return value to this function that's really just running a while true loop and executing each of these generators in the call stack. So like whatever the maximum size is for the array, and however what the maximum call stack size in JavaScript, like that's when it stops executing. If you overflow that, you'll have the same issues. It's not like we can bounce out of it. We haven't implemented tail call optimization. All of those problems are still here. All I did was move them into JavaScript instead of V8, which is way worse. But so yeah, hopefully that helps explain it. It's kind of confusing. I trial run this on a few people, and before I gave this, and it was always hard to get through this part. It's like why this yielding, this continuation actually pauses things until it's done executing. But really, this returns this function. The generator sees this and says, I'm going to yield the bouncer. And this continuation up here is really just the bouncer being passed in, and then it restarts execution when it succeeds right here. So cheat a little bit. Make sure I didn't implement. Oh yeah, there we go. Didn't actually send it. That could be a problem. Refresh this. Nope, still broken. Undefined. Am I not doing something that I'm supposed to be doing? Yes. Okay, who can tell me what I did wrong? Yes, because I break things. There we go. You guys are going to let me flounder. We're going to tell me what I did wrong, man. Who knows? Did I do it on purpose? No, one clap. Thank you, Brett. Thank you, Brett. I appreciate that. So yeah, that's what went wrong, though. Nobody wants to write all these generators and wrappers for all of these functions, like adding type annotations with TypeScript. But you know, sometimes if we want to wrap some things, we have to do this if we want it to look pretty. But
So we've actually got this. We've got this request where other things like jQuery takes a success and a failure, and then you've got dot bins and the dot catches and all these other things, and you know what? That's not normal. Nobody likes that. We like this one level of indentation for all of this logic that we have to do. But wait, so what's one of the cool things about JavaScript, right? It's non-blocking. You don't have to wait for other things to execute before you go to the next line. That's a problem. Data.ip doesn't get called until data is assigned. It's just not going to run. But man, I like my non-blocking, like all of my things running in parallel because of JavaScript, and I don't know how to write parallel code that's not single-threaded. So, what are we going to do? We're going to do threads. We're going to do threads in JavaScript, and they're going to be green threads. They're not actually going to run in parallel on the same processor because V8 is single-threaded, so we're limited by our interpreter. But we're actually going to write threads. Who thinks I'm going to do it with web workers? Oh, Tom thinks I'm going to do it with web workers. You haven't heckled me as much as I thought you would. That was just like one question. Okay, cool. We're not going to do web workers. We're going to implement actual threads. And by actual threads, I mean things that you can stop and start, but don't actually stop when you tell them to stop because reasons. And we'll get into those reasons. So our thread file is pretty empty. We should probably fill that out. Actually, you know what? Let's go ahead and take a look at how it's going to look when we're done. How we're going to use it, rather. We've got a thing that we want to run in parallel, right? It doesn't take anything, but it's going to do stuff. And we're going to make it sleep for a little bit. That's probably a long time. Let's just do that. And then we're going to let some data equal whatever the server thinks the date is right now. I'm going to call console.log instead of regular log because the log function I'm using right now prepends hour, minute, and second. And just want to see server thinks. How are we going to call this? What would be the most simple way to do this? Like for somebody who's actually writing a thread in JavaScript, right? It would be really cool if we could just do this, right? Wouldn't that be cool? But wait, we want to start the thread too, so that's kind of important. But we want that to run. Right now, that's not going to work, so I'm not going to refresh the page because it'll just error out. But we actually need to build this thing, so let's do it. This is really naive. I write better code than this at my job, promise. And yes, this looks exactly like what you think I'm about to do. Okay, so really all this does is set some properties and start something else asynchronously, right? But it starts up in our scheduler, and our scheduler knows how to control stuff. So let's go make our scheduler know how to run this thread. Technically, it already knows how to run this thread. It just doesn't know how to start and stop it, or in fact, how to stop it. So as you can see, I copy-pasted because I was starting to lose faith in myself. So live coding. So we can see it checks if we have a thread. And if we have a thread and it needs to switch the state, currently there's only going to be one of two states. There's going to be running and there's going to be not running. So we're going to stop console log that we're stopping the thread. Thread.status is stopped for anything that's actually using the thread can see the status. And then we're just going to break out of the loop. What's important here, though, is that we added another argument to the executor where it takes a thread. And because this is passed by reference and not by value, we can just go in here and pass that in. And if we want to stop the thread, we can do that. And it will change the state. We're all hunky-dory. Let's go run and make sure this works. It doesn't. Why not? Let's take a look. Are we actually calling it? We are passing in the function. Anybody tell me what I'm doing wrong? You guys were going to leave me hanging last time. No? Okay, well, I guess I'm hung. Oh, wait. Nope. See if I ever actually get there. Oh, we do. We do get here. It's running. Haven't called stop. What's our stack look like? Oh, our stack's empty. Nothing's actually being called or showing up. That's a problem. Make sure it wasn't just me mistyping something. It'd be so much cooler if it actually ran. You guys think I'm not bullshitting, but it's true. You can do threads. All right, I'm going to end up spending way too much time on this, so let's just go over theoreticals. So now, if we start this thread, and then it executes and yields and runs in parallel with this, according to however the event scheduler in V8 wants to run, this will run, and they'll run at pretty much about the same time. But because they're technically green threads, they're not actually running simultaneously. They're all still in V8, and V8 is single-threaded. If we were actually running web workers like Tom was suggesting, it would run in parallel because web workers run in separate threads. However, if I come down here, I call thread.stop, and this never called a yield. Never called either of those things. Then you have a separate problem. Both of these logs are actually going to run. Even if we had a for loop that just counted from now until infinity and just added numbers forever, even if we called thread.stop, it's never going to stop. So this is a limitation. You can't actually stop code execution. The only time we can actually tell the thread to stop is when the scheduler over here is doing stuff with the stack, and that only happens on line 55, where it calls the next generator and passes in the last value. That's the only time, and the only time the scheduler gets that is during a yield. That's the only time it can check. When it checks that, it can say, I want to stop the execution, I want to break out of this while true loop. But otherwise, the for loop that we set to run in infinity is going to continue running. I'm pointing at that screen. You guys are looking at this one. That right there on line 55 is going to continue forever if you just have a while true loop in there. We can't actually stop it. The scheduler can't have control over that. Only V8 has that. You can go into Chrome and kill the process, but other than that, you can't kill it from the scheduler. Scheduler can only stop at a yield statement, which can be a problem if you actually expected me to implement real threads in JavaScript. But you don't, right? So this is only a semi-usable threading implementation. Last night, I didn't manage to work it into my talk. There's a few things that's missing from this threading implementation. You cannot currently pause or resume a thread. It's something I got semi-working last night. It was kind of hard to add in. You have to take the context and the call stack of the scheduler, shove it into the thread, and then when you call thread.resume, it pops the call stack back onto the scheduler and then executes it. Basically exactly where it was. It just saves the stack, saves the context of the scheduler, and starts running that again. Another thing that we haven't done, and I bet somebody here has picked up on it. What haven't I done in here? What can be really bad that can happen here? Anybody? I'll give you a hint. How often do web requests work? All 100% of the time? All the time? No. If you're lucky, and your services have 100% uptime. But a lot of times, this isn't actually ever going to finish with a 200 or a ready state 4. You're going to end up with some error, and that needs to come back out. We're not actually handling that yet. Pretty sure I should start slowing this down, but in any case, if you really want to, it's actually pretty easy. You basically wrap this entire, where's my mouse? Wrap this inside of a try-catch, and in here, you check the return value passed into the scheduler and see if it's an error. If it's an error, you unwind to the stack and pass the error or throw an error back onto a generator. Now, how would you do that? No, I just said how you do it. But in reality, it's really easy. And that's it. And inside of your generator, you can actually try catch that and handle it yourself. You don't have to have all these callback if error and error nil or whatnot, and then go through all of these error checkings in your callbacks. You can literally have try catch like every other programming language that has exceptions, because exceptions. Also, if you really want to, I had a friend recommend this to me, you can do a nice little trick where you unwind the entire call stack by tossing up an exception, and can break out of really deep call stack problems. But that's not something I'm going to show here. But basically, generators are really cool. If you ever actually do this, you just pulled a Gary Bernhardt WAT, because you shouldn't be actually doing this. And to answer the question of why I did this, I'm writing my own programming language that transpiles to JavaScript, because that's a cool thing to do, right? Everything transpiles to JavaScript. And I wanted my code to actually map to what it would look like in the language. I wanted it to look like in JavaScript. And in order to do that, I wanted to implement fake threads, and I wanted it to be synchronous. So I wanted to see how I could actually do that in JavaScript. So this is the beginnings of the runtime for my programming languages in JavaScript that compiles to. Because source maps are great, but what's really nice is when you can look at your code and in JavaScript and see that this is pretty much exactly what it maps to word for word in your own programming language. And that's pretty nice. So that's my justification for why I did it. If you ever actually do this WAT. And if you find yourself doing something in JavaScript, think of the Jeff Goldblum quote. Because it seems like the JavaScript community is we just do things because we can, not because we should. This is an answer in search of a problem, and there's very few problems that actually match this right now. At least I don't know of many. I could be completely wrong. You guys might know how to use this in your everyday code all the time. And I would be none the wiser. But that's basically it. You can implement a call stack / scheduler and threading in JavaScript and still be able to do error handling inside of it. I know it was really heavy. There's It's hard to grasp. I know it was for me the first time I was doing all of this. It was the blog post I read in 2010 was incredibly long. Basically, this is a thing you can do, and it's pretty awesome. ES6 adds a lot of new things. ES7 adds even better ones. But you should definitely try generators. They're very awesome. You can build crazy stuff. And as much as I give JavaScript shit, it's pretty cool to build crazy stuff that when you show it to people are like, I never thought you could do that. And on a feel-good note, if it's in JavaScript, if you can do it in JavaScript. Jeff Atwood. That's about it. Do you guys have any questions? Because I know it was really heavy. And I don't want anybody to leave here feeling like they don't understand it. Yes? Give it Probably should have left my computer open for you.
Probably should. Oh, there we go.
Yeah, so now that we don't have code on the screen,
Uh-huh.
I'm going to
You want me to pull it back up?
memory that you have in your thread implementation.
Mhm.
You have a set timeout 0.
Mm-hmm.
And then in your scheduler, you have a while true loop that is doing running of that set timeout 0 over and over again.
Yeah, there's lots of bad
what
things
does
happening
your CPU
here.
usage look like when you're doing that giant busy loop?
See, it's actually, it doesn't look that bad.
That's very surprising, actually.
It's still an incredibly bad idea. That's why I'm saying don't ever do this. So what happens is, if you're running your own while true loop in some of that code, you're gonna have a bad time, like a really bad time. But so that set timeout 0 sets it to run basically on the next tick. Next time the event loop comes around, it picks that thing up and starts running it, and then you can control it from the main thread, so to speak. But yes, if you have something that's running for a long time inside of that while true, the CPU usage doesn't end up being too bad because the event scheduler in V8 takes care of passing off to different areas. Unless you're doing something really CPU intensive, you're gonna have a bad time anyway because you're in JavaScript. But the generators actually suspend. That's why they can't be polyfilled. They had to be implemented in V8 because the code actually stops. It literally it stops like it's its own thread in a generator. Code execution suspends. So CPU, I did run into that though. There was one point I had to kill my entire browser because Chrome was like, man, your fake threads eat everything. It's like, well, yeah, Chrome, you eat everything. But in any case, it actually ended up being okay. CPU usage is pretty decent.
Here.
Yeah, these seem real similar to async await and what's
Okay.
coming with those. How are they? I'm having trouble in my head telling where they're different or how you would use them differently based on the example.
So I'm not going to try to bullshit and say I know what those are. I've seen the keywords before, looking at C# and a couple of other programming languages, but I don't know exactly what they do. So if you could provide me with an example of something that they're good for. Yeah. I honestly don't know. Does async await just say this is going to be async and now I need to wait for it?
Yes, async.
Okay, so this case, where C# is normally synchronous, JavaScript is normally not, unless you're doing some synchronous function like that doesn't need to call out to something that takes a callback and whatnot. But by default, JavaScript is going to keep executing if you call something that's asynchronous. So I would say it's very similar, where C# is trying to be able to let you do something asynchronously without having to handle your own threading. JavaScript is that way by default, and now I want to make it look like C# instead.
Yeah, that was actually kind of my question too. Since await is part of the ES7 spec,
Oh, it is?
I was gonna wonder how you'd relate yield to that. This is still wrapping my mind all around this. Thank you for that. But yeah, I wondered if you had any comments on await coming to ES7.
I actually don't. I haven't seen that keyword yet. I need to look at that, and I am uninformed.
Okay, I think so. I'm pretty sure. But
Sorry
so he kind of
sorry
had
to
my
disappoint.
question too.
Anybody else?
Does anybody want to explain more in depth about async await and ES7?
Yeah, I would appreciate that if anybody knows.
Anybody want to do that? Hold on, let me get you the mic.
Okay.
I actually did some async await, but then moved to promises because
Okay.
it made it easier to chain them together and
Mhm.
kind of understand what was going on, and it's better supported in the current versions of JavaScript. But it's just a way to do, you mark a function as asynchronous with the async keyword, so it knows that wherever else you call it and you put the await in front of the call to that function, it will kind of pause the execution there until that's done and give you the return value, basically. I mean, that's about the best I can explain it based on my exposure.
It seems basically what I just built, so yeah, that's.
Yeah, that's why I had the question, because it seemed like the yield was doing something very similar in your example. And
Yeah.
I've seen yield used, you know, for generating Fibonacci sequences and stuff like that, where you kind of store state inside the function and yield on each successive call. But I'd never seen it used in that way, so I was wondering if you'd explored that and knew why you would use one over the other. But I guess I'll take
really
that
cool.
on as something to do later.
That's no, I'll go home and play with that, because from what I'm hearing, it sounds like I just implemented my own await using generators and yielding.
Yeah, sort of.
Learn new things every day.
All about. All right, everybody, get up for Caleb.
Thanks, guys.
So come back next week. We've got Ian Jeffries, who's been hermited away, I think, in the mountains of North Carolina somewhere, thinking about why browsers really, really suck and what he's doing to replace them. So it should be kind of an interesting talk. He's a Haskell developer. Was a part of the community here and then moved away, and so he's going to come back for a visit.